In the 1800s, scientists were conducting many experiments, trying to find out how gases would react when they were mixed together. As a result, they discovered many laws of nature. These laws did not have any theoretical proof. Instead, they could only be proved experimentally, and hence had only empirical evidence. Two such laws are Dalton's law of partial pressures and Amagat's law of partial volumes. Both these laws are very similar, but they deal with different properties. According to Dalton's law, the total pressure of a mixture of non-reacting gases is equal to the sum of the partial pressures of each individual gas. Imagine you have three containers which have the same volume, which are kept at the same temperature. If you fill each container with a different gas, A, B, and C, then each container would have a different pressure. Dalton discovered that if you took all these gases and moved them to a new container, which has the same volume and temperature, then the new pressure inside the container that has all three gases, called the total pressure, would be the sum of the pressures inside the first three containers. The pressure that the gas would have, if it was alone in the container, is called the partial pressure. So the total pressure of the mixture is the sum of partial pressures of all the gases in it. He also discovered that the partial pressure of a gas depends upon the percentage of gas that is in that mixture. To measure the percentage of gas in the mixture, we use a term called the mole fraction, denoted by the Greek letter chi. Mole fraction is simply the number of moles of that gas divided by the total number of moles in that mixture. So the partial pressure of a gas in a mixture is equal to the mole fraction times the total pressure of the mixture of gases. Very similarly, according to Amagat's law, the total volume of a mixture of non-reacting gases is equal to the sum of the partial volumes of each individual gas in that mixture. And the partial volume of a gas in a mixture is equal to the mole fraction times the total volume of the mixture of gases. The reason we say mixture of non-reacting gases is because when the gases react with each other chemically, the volume and pressure changes. These laws only apply for non-reacting gases.